Hi, so we're going to do the last problem for chapter 12 in the practice. So here I have a table, and again, your table, when you work on this, will probably be different from mine because you see the numbers in red tend to change based on the problem. So here we go. So I have a table that consists of one student athlete's time in minutes to swim 2,000 yards and the student's heart rate beats per minute after swimming one random sample of 10 days. Okay, so the swim time is in minutes and the heart rate. So they're trying to see if how his heart rate does based on how fast his swim time is, okay? So we want to see the data as a scatter plot. So what happens? So we're saying that the X is how many minutes he swims, and the dependent is his heart rate. Because if he swims a lot, his heart rate should increase, especially if his swim time decreases because he's going faster. So along the x-axis, I want to have his swim time. And you see two of these have that. So I'm just going to look through some of the variables and see if I can find which one. So I always start with the smallest. The smallest is 124. So 124 would be around 30.74. So that looks good. And then let's look at I have even small, another one, 128. So if I want to go here and look 128, and 128 is 36. So that looks about right. I'm just going to go ahead and make sure that this isn't right. So let's look at like 35, 148, and no, that's not a good one. So I know it's this one. So then the next thing it asks is calculate it using the regression, okay? We don't even really need to look at our calculator because let's go ahead and look at the one we picked, which is this one. And you just go down here and you find this one, okay? Because none of these other ones are ones that we picked, correct? We only picked the one in the top, and that correlates to the one in the top, okay? So this one right here is the same as this one right here. Okay. So what I do need to do, though, is I need to put my stuff in the calculator. So I'm going to bring up my calculator, and I'm going to move it. So I'm going to move it to over here. Come on. So you can watch me as I put it in. No, it won't move. Why won't you move? Okay. There we go. All right. So here we go. I'm going to turn on. First thing I'm going to do, second, 0, go down and turn my, let me find it. Diagnostic on, enter, and then enter again. Okay, so go to stat. So I said my X is my swim times, 34.14, 35.72, 34.74, 34.05, 34.11. Oops, didn't take the dot. So I'm just going to quickly go ahead and put all my stuff in so that it correlates. So you can do the same. And if I get ahead of you, you can always stop the video and just come back and follow me if you're doing this step by step. Oops. And you always want to make sure that you put the right values in, because if you're getting different A's and B's and R squared, then you probably either flipped your variables or you put it in incorrectly. So, all right, so there's that. Okay. So that one's in. So let me go over here. So I've got 144, 152, oops, 124, 140, 152, 146, 128, 136, oops. My calculator's slowing down a little bit on me, so. And and then 148. Okay. Got all that in there. So then I just want to go up right fast and make sure I put everything in correctly. 48, 44, 36, 28, 40. And you see me doing this because I want to make sure that I'm showing you guys correctly that I have all the data in there. So yes. Oops, go over here and let me go down. All right, so I just made sure everything's correctly. So then I go stat, I go over to calc, and I go down to number 8. You can use 4 too again if you want, but I'm just going to stick with number 8. Okay. So it asked down here, what is my slope? All right, so remember, what is your slope that we were talking about? Okay, so it's saying the slope indicates for each additional minute added to the swim time, the heart rate, will it increase or decrease? So let's go back and look at our calculator. All right, so what was my, oops, it's not good. What was my, not that one, hold on. All right, what was my slope? So my slope is negative 1.515. So that means it's going to decrease by, how much is it going to decrease? By, and it wants it in one decimal place, 1.5, okay? So each additional minute added to swim time, the heart rate will decrease by 1.5, and I know this because B is negative 1.5. So then the y-intercept indicates that if the student is not swimming at all, his heart rate would be at what per beats per minute? So let's go on here and look. So for this one, it would be 194.6. Why? That is the y-intercept. It's where the line goes through the y-axis. Okay. So let's do that one again so you can understand. Turn back on. So the first part is dealing with B, and the last part is dealing with A, okay? And again, if you use 4 function on the calculator, yours would be backwards than that, okay? So how well does the regression line fit the data? All right, so let's go look. How is my R squared looking? My R squared is not that good. So if I give it 2 decimal places, let's do 0.02. So that's not very good. That's like a small amount of the heart variation is explained by the regression equation. Whenever your R squared is really, really small, that means that X and Y really don't have anything that they're related to each other. So this association is not explained by a linear relationship. So again, if R squared is really, really small, that means that there's just a small relationship and the association is not explained by this linear relationship. All right, what points on the data have the largest residual? Okay, so what I need to do is I need to go figure out, remember we talked about outliers in the last video? So I've got to do this again, okay? So what I'm going to do is I have to go here. So I'm going to do, remember, I've got to plug in all those values into my linear, my line. So let me go ahead and do this. So let me write down my line. So it is negative 1.5 x plus 194.6. Okay. So I'm going to go back to my calculator. I'm going to hit clear. So I'm going to do negative 1.5 times, what is this one? 34, oops, 0.14 plus 194.6, enter. So this one's going to be 143.39, okay? So I'm going to keep doing this. So I think I'm going to try to do it. If you know how to use Excel, I'm going to show you the way that I can do it. You can do equals negative 1.5 times this, okay? And let me go back. Let me put this in parentheses. okay, plus 194.6. Okay, and it gives me a value. All right, what did I do? I did equals, parentheses, negative 1.5 times, and the times for this one is above the 8. I go click on this, close the parentheses, and then I add 194.6, okay? And that gives me my answer. Here is a cheat. Since I did this equation up here, I can do Control C and go all the way down and do Control V. If that was confusing to you, then just do it all by hand. Because all I did is I did the same formula over and over again, okay? So now I've got to do my residuals. So I'm going to do equals, so I'm going to do y minus this y hat. It gives me my residual. Does everybody get how I did that? I did that in the last video too. So all I did was, let me do it again, equals y minus this gives you that. And if you're doing it by hand, it's okay to do by hand. Just take your time and it'll work out. So let me do it one more time, equals y minus this y hat equals that. Okay. Since I made a formula, I can do Control C and copy that down all the way, and it gives me my residuals. Okay, looking at here, I've got to see which is the biggest residual, and I can't guess because I have a big negative and I have a positive. So let's go back to our calculator, and I have to go get the standard deviation, which is easy because the data is already in there. So I'm going to do stat, go over to test, go all the way down to here, to E. Hit enter. Everything looks good. Go down and hit calculate. And then I keep going down. So my standard deviation is 10. I'm just going to do, 10.0. Okay. So then I need to know an outlier will be 2 standard deviations above 2 times 10 equals 20. It'll be above 20 or negative 2 times 10 equals negative 20, okay? Oops, it doesn't like that, negative 20, okay. So I need to see if anything is close to that, okay? So let's look, is anything close to that? So it almost looks like this one is close to it, correct? Because it's near the negative 18. An outlier is going to be 2 standard deviations below. A residual is one that's pulling out really, really far. So I'm going to say this one, my 34.74 and my 124. So I go back here. Oops, come on. I go back here and I'm going to put my exact value in. So for this one, remember I said it was, okay, I forgot what I said it was. So it's going to be 34.74, comma, and then I've got to go get my other one. And so I go back and look at my data. It's 124. Okay, so that is that. So then what does that mean? The residual mean that when the swim time is 34.74, the observed heart rate is 124. I'm just excuse me. Sorry, hold on. The observed heart rate is about, and I need to go and I need to find my residual, 18.49. I'm looking at this right here, is 18.49 beats less than the predicted rate. When this point is removed, it has a large effect on the regression line. So it seems that it is influential. This point is not an outlier. Oops, sorry. Because the residual is less than 2 standard deviations. Okay. What the heck did I just do? All right. So what I did over here is if it was an outlier, it would have been 2 standard deviations above or below the mean. Well, I don't have anything that fits that description, but I have this point right here, which is negative 18.49. and that's the residual. That means how far it is from the rest of the data and that line that I made. So what I'm doing here is I'm showing which point it is, and then I'm saying, okay, for that x, this is the x value, this is the residual. So if I took that point out, it would have a large effect because that residual is a lot bigger than all the other residuals. So it's influential. That doesn't mean it's an outlier because it's not less than twice the standard deviation. All right. If it had been a positive residual, it would have been greater than, it would have been greater than twice, and you have to think of it in terms of that way. Okay. Let me know if this one helps or not. I know it's really confusing and kind of difficult, but take your time and it should click.